So we'll check this on Desmos, but I want to get it started without Desmos. So here's my strategy for this one. Start solving. So I would divide by 8 first. So I'll have the cosine of 4x equals 5/8. And then I'm going to apply the inverse cosine or arc cosine. So 4x is equal to the arc cosine of 5/8. And then I pause once I have an inverse trig function. I think about the unit circle for a minute. So unit circle cosine is an x value. So my x value there is 5/8. So 5/8 is more than half. So about here. Oh no, that's a y value. Sorry, take that back. Okay, about here. 5/8. And so I want the angle that goes with that. So that I'm going to call my theta 1. What angle is that? That angle happens to be the arc or inverse cosine of 5/8. Cosine inverse there because we're working out space. Now, given that x value, it also has a point over here. So there's another angle over here, and this is looking for positive solutions. So that means I'm going to head around that way to get there. So how do I name that red angle? Out of pi or 2 pi? Out of 2 pi. So the red angle, I'm going to call that one theta 2. Theta 2 is going to be 2 pi minus theta 1, which is the cosine inverse or arc cosine of 5/8. And so those are the two basic solutions. Once I have those two, I can get as many as you want from there by adding or subtracting the period. So back here, now I can deal with, I have not just an x, but a 4x over there. So for my angles, I'm going to have to divide by 4. So that's going to give me my theta 1 here, or angle 1. Actually, they want me to use x, so I'm going to call it x1. x2 is going to be like what I have for theta 2, but divided by 4. So 2 pi minus cosine inverse or arc cosine of 5/8, all over 4. So that's going to be my x2. They want a third one. So to get the third one, I would just add the period to the first one. Light this up so a little more room. So for my x3, I would take my period. What's my period here? Well, the period would be 2 pi over 4, which is pi over 2. So I would take pi over 2 plus my x1, which is the cosine inverse or arc cosine of 5/8. And just the arc cosine is divided by 4 there. The pi over 2 stays separate at that point, because that's the period of the 4x version of the cosine.
Can you explain why the period is a period? In my mind, I just would do a referencing. Would that be also?
Like, so this reference angle right here?
Yeah.
Well, that reference angle is the same as theta 1, which is nothing new here, right? So it wants another positive angle, which means I need to make a whole revolution to get to the next one. So there could be a theta 3 in this picture, which would be going all the way around past theta 2 to get to theta 1. And then adjusting for the divide by 4 for the period would be that number right there. Okay, now, I don't know if I'm right yet. I'm going to check on the calculator. So I need to calculate each of those numbers and then look at the graph to see if it works.
Before you do that,
Yeah.
is the period 2 pi over 4 because of the The 4x.
Because of the 4x. right?
Okay.
Yeah, we have, so this is, that adjusts the period from 2 pi to pi over 2.
Okay.
Yeah. All right, so then whip out your favorite graphing calculator. Desmos out. All right, so now I need my first one. I'm going to call that A equals. You can either type arc cosine or inverse cosine. I'll bring up the inverse cosine here. 5/8, right? On my version. All right, and then I have to get out of the parentheses and divide that by 4. Okay, so I think one of them is 0.2239. Now, at this point, I want to check that one right away before I calculate the other ones. And again, are you in the right mode? I'm in radian mode, which I want to be. So the original equation was 8 cosine of 4x. And I'm going to call that f of x here. And I want to know when that meets y equals 5. Let's adjust this screen because that's a lot of intersections there. It's hard to read. Let's go from -1 up to maybe 4. Should be good enough. All right, so I think I found this point right here. 22392, 22392. So I do have that one. My other calculation should come out to these numbers here. So I'm going to check that next. So my second one was fraction. And I wrote it as 2 pi minus cosine inverse. Here's a button. Cosine inverse of 5/8. And all of that was divided by 4. 134,688, and that should be this one here. 134,688. And then for the other one, call that C, I determined the period of this cosine of 4x was pi over 2. So I'm going to take pi over 2 and add it to my first solution, which I called A. So I'm just going to go 2 pi plus A here. That should be 1.7947-ish. 1, 2, 3. 1.7947. Looks like the right number. So if this problem was on the exam and you just typed it into Desmos and then just wrote those down with no work, I wouldn't be able to give any credit. I'm hoping to see something like this here, showing that you can find at least the first 2 solutions, the ones that are related to my θ1 and θ2 on the unit circle. And it's nice that we can easily check it on the computer.
We'll do 34 next.